time to continue our journey onto something called sum difference and double angle identities. Honestly, what we're going to do in the first part of these video podcasts is we're going to talk about sum and difference. We're going to look at those a little bit later on, 4 or 5 podcasts from now. Okay, so let's talk in sum and difference. What does sum and difference mean? Well, sum means to add. Yeah, of course. Difference means to subtract. So look for those things. Look for summation and difference, adding and subtracting. Well, why do we use these? Well, because the identities can actually be used to determine exact values. So the worst thing is I see people throw stuff in their calculator, give me all kinds of decimals, and of course, dealing with pi gives you a repeating decimal that never ends. So you're not dealing with an exact number. Ugh, rounding kind of sucks. But the other thing that we can use this for is we can use for verification and simplification of trigonometric expressions. This is really, really cool because if it can simplify things, we can verify things, we can do things algebraically. Okay, enough talk. Let's just go on already. Okay, I will. Important note. Some of the rules we use in algebra, though, folks, does not apply in trigonometry. For example, if you look at this algebra, you know and I know we've got a 3 up front here. We would just go distribute this like that, distributive law, no problem. We'd get 3a and 3b, da-da. But in trigonometry, you can't take this sine or the cosine and the tangent that's the outside of the bracket and distribute this. It just doesn't work. So in other words, you can't get just sine x plus sine y or cos x plus cos y, tan x plus tan y. That just is a big, huge no-no. That's where identities come in, folks. That's what's going to help us solve things like this and know that we're not going to do it wrong. I'll prove it to you. I've got a great little example right down here that I need to show you. This is very cool. So let's assume x is pi over 2 and y is pi over 6. So we're going to use this idea of taking sine of x plus y and see if it actually works out to be sine x plus sine y. I just told you it didn't, but I want to prove to you that it's not. All right, so let's take a look at this side. This side's really, really cool because it's the easiest side to work with. We're going to take pi over 2, right? And we're going to add it to pi over 6. Okay, so first things first. Common denominator, there it is. So this is 3 pi over 6 plus pi over 6 to give you, of course, 4 pi over 6, right? So check this out. 4 pi over 6, don't forget, we still have a sign up front here, so that means this has got the sign up front here. So what is the sign of 4 pi over 6? Wait a second, can't we make that a little bit simpler? Sure can. This is the sign of 2 pi over 3. Aha! That makes sense to me now. Okay, so just like we did before, let's actually find the value of sine at 2 pi over 3. Okay, there's 2 pi over 3 there. Okay, you know and I know that's 1/2 root 3 over 2. Of course, it's a minus 1/2 because we add sugar to coffee, right? Okay, so what's the value of the sine of 2 pi over 3? Oh, okay, that's easy enough. That's root 3 over 2. So this whole mess that we have here, this whole thing that we have here, right here, this guy, is actually equal to root 3 over 2. Now, I want to prove to you that it doesn't equal. Okay, so find me the sine of pi over 2. Well, I can do that. Pi over 2 is one of those quadrantial points, okay? And you know that that point, of course, is 0, 1. So the sine of that, oh, well, that's easy. That's 1. Plus the sine of pi over 6. Okay, pi over 6, you know, is the thinner one over here. So that's root 3 over 2, 1/2. Okay, so the sine of that is 1/2. Common denominator, 2 over 2 plus 1/2 gives you 3 over 2. Look how this answer, the right-hand side, which is 3 over 2, does not equal to the left-hand side, which is root 3 over 2. They do not equal. So that means you cannot distribute a sign. There's got to be something else. So before I do that, let me make sure that you see it right in front of you, right here. Trigonometric functions are not distributive. Really important to realize that. And this little exercise we did just here proves it. Okay, so how do you do this? You got to have an identity. Check this out. You have 6 of them now. Well, think about it. You got sine, cosine, and tangent. For the sum, there's 3 of them. You got sine, cosine, and tangent. For differences, another 3, total 6. Yippee skippy, right? Okay, so how do you know which one to use? Well, think about it. If it says sine and it says add, you're going to use this one. If it's a cosine and you're going to use this, and same. So it's actually really easy to figure out. All you got to do is realize what are you working with and then just substitute it in. Well, how do I do this then? Well, simple. Let me show you. Watch this. Dun, 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 dun. I'm just going to move it up just enough. Look at this. Look what I have right now. That's the difference. Okay, so I'm not going to use this side. I'm going to go right over to the different side. I'm going to find sine. Oh, there's the sine one. There's the difference. So how do you know which one's A, which one's B? Well, first one's got to be A. So wherever you see an A now, put pi over 2. Simple. Pi over 2A, pi over 2A, pi over 2 for A. Beautiful. Now, check this out. Wherever you see, this has got to be the B value, right? Because it's right here. So B is X, B is X, and B is X. Now, rewrite this thing in terms of the identity we just figured out. So in other words, all I want you to do is write this guy out. Watch this. This is now sine of pi over 2, right? Cos X, and there's the subtraction sign there. Okay, good. We've got cos pi over 2, and then finally sine of X. Oh my goodness, that's so easy now, right? Because you know and I know that pi over 2, we can actually find the exact value. There's pi over 2. It's one of the quadrantial points. You know that quadrantial point to be 0, 1. Beautiful. Okay, so the sine of pi over 2 then, of course, is the y value. That's 1 times cos of x. Well, we don't know what x is, so we'll just leave it as cos of x. Now, the cos of pi over 2, oh my, hey, that's 0, which makes this minus 0 times the sine of x. Well, wait a second. What's 0 times anything? 0 times anything just cancels out, gives you 0. So you got 1 times cos x. So this actually works out to be cos x. So something this complicated ran through the identity just to give us something real simple. That's the whole point of this, folks. Take something that's kind of strange, put it into an identity, make it something simple that we can understand. Beautiful. Let's do B. Hold on. Little podcast magic for you, hey? Yeah, I know. Watch this. Here's B. Look what you got. You got oh my goodness, that's a sum. Okay, so let's go over and use the sum ones. This obviously is a cosine, so I'm going to use this one right here. Beautiful. My A is 90 degrees. So wherever I see A, I'm going to put in 90 degrees. 90 degrees there, 90 degrees there, 90 degrees there. Oh, yippee skippy. Okay? My B is got to be X. So wherever I see my B, I'm now going to substitute an X. There's an X, there's an X, there's an X. Boy, this is easy. Look at this. Watch this. This becomes, just read it, just like you see it there. Read it. Cos 90 degrees, cos X. Oh, careful. Even though this is a sum identity, according to the identity itself, it is a subtraction. Be very careful. Okay? So this will be subtract sine of 90 degrees, sine of x. Beautiful. Let's go and figure this out. Okay. Right on. 90 degrees, we know is right here. It's a quadrantial angle. Perfect. Oh my goodness. We know that that is, again, 0, 1. So here we go. What is the cos of 90 degrees? Cos of 90 degrees. Oh my goodness, that's 0. 0 times cos x minus, what's the sine of 90 degrees? Oh, that's 1. Oh, beautiful. 1 times, oh, you got sine x here. Beautiful. Now, check it out. 0 times cos x, that in fact is 0. Minus 1 times sine x is sine x. So guess what? Yep, this works out to be a nice, simple little sine x. See? Again, using the identity, break this thing down into something simple. All right. Now, let's take a look at item C. The tangent ones, remember, I've always said tangent is its own little beast. check this out. You know it's a sum identity, so you're definitely going to use this tan right here. But check this out. Oh my goodness, is this ever a gross looking identity? Yep, sorry, that's just the way it works. And the reason why it's that way is you have to remember that tan is that sine over cos. That's what makes this into just a very looking fraction. But who cares? Look, that's your a value. So wherever you see a, put an x, right? So there's an a, there's an a. Beautiful. There's your b value, pi over 6. Okay, so there's my pi over 6 for b and pi over 6 for b. Oh, well, that wasn't so bad. Come on, really? Okay, so here we go. We have tan x. This will be tan x plus tan pi over 6 over 1 minus tan x, okay? That's not so tough, times tan pi over 6. Oh, beautiful. Okay, we know what pi over 6 is. Let's go. Pi over 6. Pi over 6 is right here. Remember, this is root 3 over 2, 1/2 for pi over 6, right? Okay, beautiful. Now, remember that tangent of an angle, whatever the angle is, okay, I'm just going to use theta, is of course sine theta over cos theta. So remember, sine theta is 1/2 over cos theta, which is root 3 over 2. Okay, remember what to do now. So this is going to be then 1/2. Let me get rid of this so we can have a little bit more room. This is going to equal to 1/2 divided by root 3 over 2. And of course, that's going to be 1/2 times the reciprocal of 2 over root 3. Ba, ba, ba. Answer 1 over root 3. Many people have already memorized that, but if you haven't, you got to go out and work it out. Okay, so what does that give us? All right, well, tan x doesn't change. There's no value for x, so just write it down as tan x. Beautiful. Plus, oh, there's our tan of pi over 6, which we know is 1 over root 3. Yippee skippy. Over 1 minus, okay, tan x, we don't know, but tan pi over 6 is that 1 over root 3. So I'm going to write it down as tan x times, I'll put it in brackets, 1 over root 3. Now, that looks kind of ugly, doesn't it? Well, unfortunately, the only real thing that you can do here is probably just rewrite the bottom and say 1 minus 1 over root 3 tan x. Because remember, this is multiplication, so it doesn't matter the order. But honestly, that's it. So yeah, that's not the prettiest thing in the world, but if we knew the value of x, we can throw it in there and find an actual numeric value. So this gives you a nice introduction to sum and difference identities.